Something is happening right now in our solar system that has every major space agency on edge. For the third time in human history, we are tracking an interstellar visitor, an object that didn't originate from our sun, our planets, or even our cosmic neighborhood. It came from the deep dark between stars, a region where no natural body should behave with precision or intention, yet this one has. The object known as 3I/ATLAS has just done something no comet, asteroid, or frozen piece of cosmic debris has ever been observed doing. It changed course, not slightly, not gradually. Not because of jets of vapor or gravitational nudges. It changed direction in a way that breaks every known law of orbital mechanics. This shift was so unexpected, so clean, and so perfectly timed that the International Asteroid Warning Network, an organization normally concerned only with Earth-borne threats, was forced into emergency tracking protocols. For the first time ever, the IAWN has begun treating an interstellar object like a potential hazard. And the question is, why now? Why this object? And what did the world's top observatories see that triggered their immediate coordinated reaction? Because according to the Jet Propulsion Laboratory, according to ESA's orbital models, and according to the fundamental rules of physics that govern motion in the vacuum of space, 3I/ATLAS is not where it's supposed to be. If this object really executed a lateral maneuver while near the sun, a direction no natural comet can turn, then what we are witnessing may not just be an anomaly, it might be intentional. Something may have guided it. And as we'll uncover in the next few minutes, the deeper we go into the data, the more disturbing this becomes. Because what happened next, what James Webb, Gaia, and multiple observatories detected, suggests that 3I/ATLAS may not be drifting through our solar system at all. It may be navigating it. Interstellar objects are among the rarest phenomena humans have ever observed. Before 3I/ATLAS, only Oumuamua in 2017 and 2I/Borisov in 2019 had ever been confirmed as visitors from outside our solar system. Both triggered global debate, but neither caused the kind of coordinated defensive response we are witnessing now. Why? Because neither object behaved like this. 3I/ATLAS arrived with an unusual set of characteristics. A strange anti-tail pointing toward the sun, a rotation rate that didn't match its size, and a brightness pattern that suggested structural irregularities. Even before the course change, scientists were already uneasy. Something felt off. Interstellar comets should behave like frozen relics from distant star systems, passive, inert, following predictable gravitational arcs. But 3I/ATLAS entered our system on a steep inclination, flared with unexpected jets, and produced a tail reversal that no natural body has ever demonstrated cleanly. The reason the scientific community cares is simple. Interstellar objects carry secrets. They contain material forged in alien environments, shaped by suns we've never seen and planets we'll never visit. But they also act as messengers. By studying their movement, composition, and behavior, we learn about the mechanics of the galaxy itself. Except in this case, the message isn't about chemistry or physics. It's about control. If an interstellar object is altering its own trajectory, then something, somewhere, engineered it. And if that's true, then humanity has just encountered its first evidence of technology not built by human hands. The International Asteroid Warning Network wasn't supposed to be involved in something like this. For years, the IAWN focused exclusively on predictable, homegrown threats, asteroids native to our solar system, debris fields, fragments of ancient collisions that occasionally drifted close to Earth. Interstellar objects were outside its mandate. Oumuamua wasn't tracked by them, neither was Borisov. They were curiosities, not dangers. But everything changed in late October 2025. Before the public even noticed anything unusual, the IAWN quietly circulated an internal bulletin to its member agencies. It did not read like a scientific update, it read like an alert. A deviation had been detected, small at first, but persistent enough to trigger concern. Their message wasn't about discovery, it was about preparation. Something in the tone of the memo suggested urgency, as if they were reacting to data that hadn't yet reached the public. Officially, the IAWN announced they were tracking 3I/ATLAS to improve astrometric precision and better understand interstellar cometary behavior. Unofficially, the timing raised eyebrows across the astronomical community. Just days before the announcement, the object had slipped behind the sun, entering a blind zone where Earth-based observatories had no visual access. That blackout window was long enough for something unexpected to happen, and according to independent astronomers, something did. When 3I/ATLAS emerged from solar occultation, its position was off. Very off. The discrepancy wasn't catastrophic, but it was unmistakable. The math stopped working, as one research team described it. Objects don't simply ignore physics on one side of the sun and reappear behaving like nothing happened, unless something acted on them during the blackout. Harvard astrophysicist Avi Loeb, already vocal about his belief that interstellar objects required serious consideration, escalated his evaluation. He had previously rated Atlas a 4 on the Loeb scale, the likelihood that an interstellar visitor might be artificial. After the deviation, he raised his assessment publicly, stating that the anomalies should not be dismissed as mundane until evidence proves otherwise. Inside the IAWN, the object was reclassified from a scientific interest body to a priority target, a designation normally reserved for potential impact risks. Overnight, hundreds of telescopes, government, university, and private, were retasked. Radio dishes were realigned, deep space tracking schedules were rewritten. It was clear something had frightened the experts, even if they refused to admit it publicly. What made the situation even stranger was the IAWN's behavior afterward. Their public posture remained calm and clinical, but their behind-the-scenes movements were unmistakably defensive. They weren't studying a curiosity. They were preparing for an unknown, and 3I/ATLAS was only beginning to reveal its secrets. The first undeniable sign that something was wrong didn't come from NASA or ESA. It came from a small group of independent astronomers known as Earth Exists, a research collective that specializes in verifying orbital predictions using real-time sky data. When they compared their telescope observations with JPL's official trajectory model, they noticed something alarming. 3I/ATLAS was gone from its predicted location, not by a few kilometers, not by a minor drift, by 1.1 million kilometers. To put that into perspective, that's nearly 3 times the distance between Earth and the Moon, an error margin impossible for any competent orbital model, and the discrepancy wasn't random. The object's distance remained nearly consistent. What changed was its lateral sky position. In other words, it didn't move closer or farther from us, it moved sideways. Nothing in nature produces sideways acceleration in the vacuum of space. Comets only accelerate along their orbital path due to sublimation jets gravity only pulls inward along predictable vectors. Even solar radiation pressure works in straight outward lines, but 3I/ATLAS didn't obey any of these forces. Its trajectory bent cleanly, as if something underneath or inside it had fired, nudged, or pushed it along a new vector. Even the most active comets in recorded history, including Hale-Bopp, could not achieve a maneuver so precise and so sudden. At first, some astronomers tried to dismiss the shift as a data glitch. Maybe one observatory had corrupted readings. Maybe the sky positioning tools were miscalibrated, but then the European Southern Observatory verified the deviation. Japan's Subaru telescope confirmed it. China's Purple Mountain Observatory independently observed the same lateral displacement. But what truly rattled the scientific community was how the maneuver appeared in the data, not like a gradual drift, but as a clean, almost instantaneous vector adjustment, like the kind spacecraft execute using attitude thrusters. Even more unsettling, follow-up observations detected no plume, no dust fan, no thermal spike at the moment of the shift. Whatever caused the lateral change left no visible wake. It moved like something designed to minimize signatures, something aware it was being watched. The verdict was in. 3I/ATLAS had maneuvered. This was the moment the narrative changed from strange comet to possible spacecraft. But the story was about to escalate even further, because the next anomaly didn't come from Earth. It came from Mars. In the weeks leading up to the maneuver, NASA's Mars orbiters had a front-row seat to 3I/ATLAS's solar flyby. MAVEN and MRO were positioned perfectly to capture high-resolution images as the object passed within observational range. But despite ideal geometry and the capability to photograph it, not a single frame from Mars has been released. NASA stated that the imagery is still under review. But insiders whispered another explanation. The images revealed something that could not be explained away as a comet, something geometric, reflective, or structured. This is where the behavior of the tail became impossible to ignore. Before the maneuver, 3I/ATLAS exhibited an anti-tail, material pointing toward the sun instead of away from it. This can happen under rare circumstances, but after the Mars encounter, the tail suddenly flipped directions and aligned like a normal comet, almost as if the object had reoriented itself to change how sunlight interacted with its surface. Avi Loeb noted this reversal in a recent publication, calling it highly suspicious and indicative of controlled orientation. His criticism wasn't that 3I/ATLAS was behaving unnaturally. His criticism was that NASA was refusing to release data that could clarify the behavior. And then there was the elevation of the object within IAWN's monitoring structure. A simple comet doesn't trigger asteroid defense protocols. Comets don't prompt encrypted alerts. Comets don't cause emergency workshops for astronomers to learn how to track unpredictable and dynamic objects. Behind the scenes, however, the Mars data became a subject of heated internal debate. Several unnamed engineers leaked that the infrared signatures collected during the flyby did not match frozen ice or dust. Instead, the spectra contained sharp thermal gradients, patterns more akin to radiative heat coming off structured surfaces or metallic composites. Even stranger, one leaked report suggested a brief specular reflection consistent with a flat, possibly angular face, rotating momentarily toward the orbiter. NASA's silence became the loudest warning of all, because if they had nothing to hide, the images would have been released immediately. The fact that they weren't suggested one thing: the anomaly wasn't just real, it was undeniable, and that meant the world needed to prepare for whatever came next. By late October, the truth broke open. Multiple observatories confirmed that the trajectory deviation wasn't just a one-time drift. It was sustained over a span of 19 hours. 3I/ATLAS maintained a lateral displacement consistent with a velocity of about 4 kilometers per second. That level of sideways motion is utterly impossible for any natural comet. Solar wind doesn't push sideways. Outgassing jets can cause rotation, but cannot drive sustained lateral thrust, especially not with such precision. And gravitational forces cannot create sudden, angular changes in deep space. The collective conclusion was chilling. 3I/ATLAS exhibited deliberate propulsion. IAWN classified the behavior as a pattern recognition event, meaning the motion matched no known natural profile and resembled controlled navigation. Behind the scenes, astronomers realized they were witnessing something humanity had never observed before: an interstellar object that could accelerate itself. That's when infrared analysis from the European Southern Observatory revealed a thermal spike. For 12 minutes, the object emitted heat, far exceeding what sunlight could explain. Then the heat signature dropped to baseline, as if whatever mechanism caused the burst had switched off. Scientists compared the spike to known propulsion models. It did not match chemical propulsion. It did not resemble ion drives. Instead, the pattern matched theoretical magneto-hydrodynamic acceleration, the kind of propulsion system we believe could power interstellar travel but have never successfully built. Just as disturbing was the change in the object's rotation. Previously stable, the rotation rate began oscillating with perfect harmonic regularity every 247 seconds. Natural tumbling is chaotic. Natural rotation changes randomly. But this oscillation behaved like a timed signal, pulsing through the void with mechanical precision. As monitoring intensified, researchers began to notice something subtle but alarming. Each time the harmonic pulse peaked, faint electromagnetic interference appeared in deep space networks. It wasn't enough to disrupt communication, but it was enough to be measurable, almost like a heartbeat, steady, intentional, and powerful enough to ripple across millions of kilometers. As more data flowed in, the planetary defense offices of multiple nations quietly elevated their risk posture. The world was now watching the skies with growing dread, because 3I/ATLAS wasn't just moving, it was choosing where to go. But the next event would push the world past concern and into outright fear, because after proving it could accelerate, 3I/ATLAS would soon prove it could do something even more shocking. It could correct its own path. Just when astronomers began mapping the anomalous drift, 3I/ATLAS executed a second maneuver, this time a precise course correction perfectly aligned with its original trajectory. The shift was subtle but unmistakably symmetrical, like a spacecraft performing a navigation update after an automated system check. The global reaction was immediate. NASA doubled its monitoring cadence from twice per day to every 20 minutes. China activated its U-22 lunar radio array. Technology normally used only for deep space communications. ESA triggered emergency protocols from its Planetary Defense Division, even though the object was moving away from Earth. The deeper scientists looked, the more impossible the behavior became. The 247-second rotational pulse grew sharper, more defined. At first, many believed the object was simply tumbling, but natural tumbling cannot stabilize itself. It cannot harmonize, and it certainly cannot maintain a perfectly repeating interval. This pulse looked like communication, motion used as signal. As the second maneuver unfolded, global observatories began scrambling. Private institutions in Chile canceled scheduled research to track the object exclusively. Japanese observatories reallocated their deep-field telescopes. The Max Planck Institute issued an internal memo calling the event unprecedented in modern astronomy. And then came something unprecedented. Hints of a repeating optical flicker on the edge of the visible spectrum. These flickers seemed to align with the rotational pulse, almost like a visual counterpart to the electromagnetic heartbeat. Observatories noted that the flicker intensity increased when sunlight hit the object at a specific angle, suggesting that reflective surfaces or structured geometry might be involved. But the most concerning shifts were happening behind the scenes. Expert workshops on rapidly changing cometary dynamics filled within minutes. Planetary defense centers began simulating worst-case scenarios, even though the object wasn't approaching Earth. And a quiet coalition of private observatories, normally uninterested in defense issues, began coordinating their own encrypted data sharing. They were preparing for something none of them wanted to say out loud, the possibility that 3I/ATLAS was not a comet at all. Then came the event that would shake the entire astronomical community. Because after demonstrating 2 controlled maneuvers, the interstellar object was about to prove it could do something even human spacecraft struggle with: disappear. On a quiet night in November, every observatory tracking 3I/ATLAS went dark at the same moment. In Hawaii, Chile, Spain, Italy, and South Africa, screens froze mid-frame. Tracking software crashed simultaneously. Telemetry streams dropped to 0. Even China's deep space arrays reported total silence across multiple frequencies. Nothing like this had ever happened before. For 47 minutes, the world saw nothing. This wasn't a communications failure. This wasn't a solar interference event. This was a synchronized blackout affecting dozens of autonomous systems spread across multiple continents. When the data streams returned, they all showed the same shocking result. 3I/ATLAS was gone, not destroyed, not hidden by the sun, simply missing. But as analysts reviewed the logs, a pattern emerged. During the blackout window, several observatories detected faint but consistent distortions across the ultraviolet spectrum. Brief shifts that looked almost like gravitational lensing. These distortions were small, irregular, but synchronized across continents. Whatever 3I/ATLAS did, it bent light around itself. Then came the faint flash, recorded during the downtime. A directional spike of reflected light aligned perfectly with Jupiter's orbital path. The implication was terrifying. 3I/ATLAS hadn't vanished, it had moved. When Webb regained visuals, it detected a reflection tens of millions of kilometers from the object's previous location. Moving at a velocity that contradicted the speed of light limits, Gaia observed a second reflection 247 seconds later. The timing was exact, too exact. Some theorized the object had executed an instantaneous vector relocation, something like a gravitational jump, using geometry rather than propulsion. No known natural object can do this. No human vessel can do this. Then researchers found something else: low-frequency electromagnetic echoes repeating faintly across deep space network antennas. At first, they seemed like noise, but when processed, the echoes aligned perfectly with the 247-second rotational signature, as if something was calling back, as if something wanted to be noticed. And then came the most disturbing discovery of all: a partially corrupted binary transmission embedded inside the blackout window. Something had piggybacked on the global loss of telemetry. Something had inserted information into the network itself. When decoded, the information wasn't a trajectory, a velocity, or a structural signature. It was coordinates. Coordinates in the future. At first, the decoded coordinates made no sense. They pointed to Jupiter's orbital region, but with a timestamp 6 years ahead. Investigators assumed it was corrupted data, but as the reconstruction continued, the truth became clear. The coordinates weren't for Jupiter's future location. They were for Earth's. According to the decrypted data, 3I/ATLAS had plotted a return point, an exact intersection with Earth's orbital plane in the year 2031. The timestamp was precise to within hours, the angular solution was accurate to within kilometers. This wasn't an accident, this wasn't random cosmic drift, this was a schedule. IAWN immediately locked the file under Omega-level protocol, the same classification reserved for civilization-ending threats. NASA, ESA, and JAXA denied all knowledge of the transmission. China erased weeks of tracking logs. Russia went silent entirely. But the truth refused to stay buried. 3 months later, amateur astronomers in Australia detected a faint radio pulse repeating every 247 seconds, the same harmonic signature 3I/ATLAS emitted before the blackout. But this time, the signal wasn't coming from beyond Jupiter. It was coming from inside the asteroid belt. Something was circling back, and then something even stranger happened. The pulse began to modulate, not in frequency, but in amplitude. The changes were small, almost imperceptible, but consistent across all detected signals. To some, it appeared like a countdown, tiny shifts marking elapsed intervals. To others, it looked like an encoded message, possibly a telemetry handshake looking for a response. Project Helios scientists speculated that the modulation could be part of a navigation system, an interstellar object preparing for timed re-entry into the inner solar system. If true, then 3I/ATLAS wasn't simply waiting, it was calibrating. And calibration means intention. The implications were overwhelming. 3I/ATLAS wasn't fleeing our system. It wasn't lost, confused, or drifting. It was planning something, and every new signal suggested the same thing. The object would return in 2031. After months of silence from national space agencies, the world's astronomers realized the truth. Official channels would never reveal what was coming. In response, a private, encrypted coalition of observatories was formed behind closed doors. Its name leaked months later, Project Helios. Its purpose was singular: track the returning signal and prepare for whatever 3I/ATLAS had become. Unlike IAWN, Helios had no political oversight, no jurisdictional limitations. No reason to hide what it found. And what it found was chilling. Every 247 seconds, a faint pulse still echoed across the solar system, a whisper of the object's final rotational signal, too weak for casual detection, too consistent to be random, like a beacon waiting to be recognized by something that knows how to read it. Some believe 3I/ATLAS is performing reconnaissance, mapping gravitational wells, testing orbital alignments, studying our resonance. Others believe it isn't moving unpredictably. It is following a plan. Maybe it isn't fleeing. Maybe it isn't lost. Maybe it's coming home, because the last time it maneuvered, the last time it flashed across our skies, the decoded message pointed here, toward Earth, toward our orbital path, toward the year 2031. And now, as observatories begin to pick up faint echoes in the asteroid belt, one truth becomes impossible to ignore. The story of 3I/ATLAS is not over. It is only beginning. Even stranger, sensors have begun to register a new phenomenon: micro-lensing distortions occurring in the exact regions where the pulses originate. These distortions are too weak to be gravitational waves, too structured to be noise. Some astronomers believe the object, or whatever remains of it, may be preparing another relocation event, possibly a controlled insertion into a new orbit. And if that orbit intersects Earth's path in 2031, humanity may face its first interstellar encounter, whether peaceful, scientific, or catastrophic. So if this discovery made you question what's really traveling through the void, if it made you wonder what intelligence could cross interstellar space, if it made you curious about what might return in 6 years, don't look away, subscribe. Because when 3I/ATLAS comes back, the world may witness the first contact event in human history. And this time, it might not just pass by, it might be heading for us.